Our lesson today is how to convert fractions, decimals, and percents. So we're looking at how fractions and decimals and percents are all related to each other in this lesson. So let's say that we were looking at an apple, and that apple was cut in half. So we're looking at the top of the apple with the stem and the leaf and everything, and we've just cut that apple in half. Okay, so our fraction for this part of the apple would be 1/2. Okay, this should be review at this point. What would the decimal equivalent be? 1/2? Well, if it's a decimal, we have a tenths place here. So we basically need to think of 1/2 as how many tenths? Well, if we're at the halfway mark, then that would be 5/10. Okay. And I'm going to throw some 6th grade math in there for you guys today and get you thinking about percentages. Percent means for every 100 because cent means 100, like 100 cents in a dollar or 100 years in a century. So percent means per 100. So out of every 100, this is how many we would have. So the trick for that is to take your decimal of 0.5 and then we'll move the decimal over 2 places, which brings us into whole numbers and whole number land again. We'll go 1, 2, and that's where the new decimal place goes. But then we have that funky gap, that space. Well, what digit do we use to be a placeholder? The 0 digit is a great placeholder. So we now have 50%. 50%, which would be an F or a 1 on a test. Okay, so we had several ways of showing this half of an apple. We had 1/2, which is the same as 5/10, which is the same as 50/100, which is the same as 50%. And here's a way that you can remember the moving the decimal 2 places. Gear up for it, guys. It's going to make you laugh, but it'll make you remember. Butt cheeks. Yep, I said it. There they are. It helps you remember. You're moving the decimal over 1 place at a time and just going over 2. So that might be a helpful little hint that helps you a lot. So we saw that 1/2 is the same as 0.5 is the same as 50%. Well, we found in the previous example that halfway could represent a lot of different Another way of thinking about 1/4, and often we say it this way, we could say 1/4 or we could say 1/4. Okay, quarter. When we think of money, we think of quarters and dollars and coins, and quarters are one of them. And how much is a quarter worth? 25 cents, which is 25/100, because cent means hundredths. So if we were to put that 25 cents in decimal form, we'd have 0.25. So there's your decimal equivalent for the fraction 1/4 is 0.25. Now, if we want to get it to a decimal, you know what's coming. Butt cheeks. Yay! We have a new place for the decimal. So we now have a whole number that we can be writing as a percent. So we will have 25%. And that percent, again, means per, or for every, cent, 100. So if there were 100, you would have 25. 25%. Let's take a look at this 10 by 10 array with the green line down the middle of it. This array is going to be a model for our decimals and fractions. It shows 100 hundredths. All those square boxes are hundredths, and there are 100 of them. And it also shows 10 tenths. We can see a tenth as one long column. A long column or a long row would be a tenth. There are 10 of them in this whole array. And that 1/10 could look like this with a fraction. It could look like this with a decimal. Or it could look like that with a percent. Please make sure that you've got all of this written in your how-to books. Now I have a green line down the middle there. That green line is going to represent how we first cut that apple in half. Except now we're not working with a fruit, we're working with a grid model, which is just fine. So, we cut that apple in half, and we already figured out that 1/2 is the same as 0.5, or 5/10, and that's the same as 50%, because it's half of 100. And then we got a little funky. Then we went over to our peach and we ignored a half because we already had figured that out. But then we did something new and different. We made a 1/4. Which means up here we also have 1/4. So in our first area over here, we had a half. We split that half into fourths. So if we can split fractions that way and just keep doubling the denominator as we cut it into smaller and smaller pieces and we get more and more of them, there's a pattern for decimals too, and it's a pattern that I was never taught in school, and I just learned it in my teacher class, and my jaw just dropped. So I'm really excited to share this with you guys. So if 1/2 is the same as 0.5 for the decimal, or basically 0.50, you don't really need the decimal there, but it's going to help in this case. And a 1/4 is a half of a half. Could we cut this half in half and get our decimal equivalent for 1/4? Well, absolutely. Check it out. If we cut the fraction in half, we get 1/4. If we cut the decimal in half, we get half of the number that we started with. In the first case, we had 50 hundredths, same as 5/10. If you cut 50 in half, you get 25 hundredths. So 50 hundredths cut in half makes 25 hundredths. And this is going to be a pattern that can help us even more. So if we know how to get from 1/2 to 1/4, just by cutting those numbers in half, could we cut them in half again? Could we get to 1/8? Let's try it out. Let's see if we can. I like eighths, so I'm going to pick my favorite color, purple. Have is the verb that means to cut in half. So let's use the verb here. I'm going to have my 1/4 and have my 0.25. Okay, if I have my 1/4 and chop it into a smaller piece, I will get 1/8. And this was the big revelation for me here. I can have my 0.25, my 2500ths, and get the equivalent decimal for 1/8. It's a tricky one. And in all my life, my teachers just said, yep, that's just one you have to memorize. They didn't give me this strategy. And guess what? I never memorized it, not until this strategy. So if you had 25 of something and you had to cut it in half, this one's a tricky one. But it's an odd number, so it's not going to be even. Let's just pretend like it's 24 for right now. We can put the other one back later. Let's pretend like it's 24. What's half of 24? Well, half of 24 is 12. But then we also still have to take care of this 5 over here. This represents a whole nother number. So we've got 12 that goes into 24, but then we have one more number that we need to have, that we need to split in half. So that would basically be one number split in half would be a 0.5. So if you were thinking about it as just 25 split in half, it would be 12.5, but that's kind of cheating because, hey, we've got this decimal there. So the decimal's going to need to stay in the same place. But if you think of half of 25 as 12.5 or 12.5, that's where you're coming in here. You've got 1/10, 200ths, and 5,000ths. So you would say this, like a math pro, 125 thousandths. That's going to be one that you need to either memorize or know how to have the 2500ths, the 0.25, and get a half of that. If you can memorize your fourths as 0.25 and your eighths as 0.125, you're going to be able to figure out anything with fourths or eighths in it because you can just add on those groups of fourths or eighths. So we just determined that 1/8 is the same as 0.125. Well, these are not really friendly numbers. So if I said, well, what are 6/8? You might be thinking, oh my gosh, I have to add 0.125 plus 0.125 plus 6 times? Well, lucky for you, if we look at the numbers, we're going to find some shortcuts together. Let's try 2/8. Could 2/8 be simplified into another fraction that might be helpful? Yeah. 1/4. 1/4. What's the value of a quarter? 0.25. Or you could have added the 0.125 plus another 0.125. Add it up. See what you end up with. Hey, you ended up with 0.25 all over again. So either strategy is just fine, but if you really take some time to think of the numbers and simplify them, you might already have some friendly decimals waiting for you. Okay, 3/8. Not so friendly. You could add 0.125 plus 0.125 plus another 0.125 and get your answer. Or could you work with what you already know? Maybe do 0.125 plus 0.25. Remember, we line up with place value here. Let's get an extra 0 in there to hold that place. So 3/8 equals 0.375, using the facts that we've already learned. So then, what about 4/8? We could do 0.125 plus 0.125 plus 0.125 plus 0.125. We could build on the addition that we've already done with our decimals, or we could just look at the number. 4/8 would simplify to what fraction? Yeah, a half. And do you know the decimal for a half? You should. 0.5. So that's the first bit of the eighths. Before we go on with the rest of the eighths family, I want to show you guys something that I learned from a teacher recently. And I don't even know her name, but she had a great idea, and I am really excited to share it with you. So going to that 10 by 10 grid that represents hundredths, she divided it in half, and then she divided it in half again, all the while wanting to get down to eighths. She divided it in half again, and she said, well, if I started with halves and I split those up, then I have fourths. So it would make sense that if I split the fourths up into equal pieces, that I would then have eighths. And look how she did it. Make sure that you're writing all of this down in your notes. That's how she did it. So each of those triangles is the same size as all the others, and there should be 8 of them. Let's count and make sure. 1, 2, 3, 4, 5, 6, 7, 8. So we now have eighths. And if you look really carefully, you can actually see the decimal in there. Now, what did we say that our eighths were worth? 1/8 was worth 0.125. Let's see if we can find the 0.125 within one of the eighths. Okay, I'm going to get to yellow because it's kind of a highlighting color here. And I think I'm going to use a bigger circle to point it out. Okay, first let's count the hundredths, because each square is a hundredth. So there's 1, 2, 3, 4. Oh, I can't do the next one because it's not an entire hundredth. Okay, so starting at the bottom again. 5, 6, 7, 8, 9, 10. Okay, so far, that's 10 hundredths. Okay, well, but we also have these little triangles. How much is one of those tiny little triangles worth? Each one of those triangles is worth half of a hundredth. Woohoo! Okay, so let's count the halves. 1, 2, 3, 4, and 5. Could we put any of those together to make another box, another hundredth? Yeah, these two go together, brings our total to 11. These two could be put together. That brings our total to 12. But what about this guy? Well, looks like we have 12.5 hundredths. 12.5 hundredths. Let's see, how would we write that as a decimal? So 12 hundredths and another half. Well, we know our digit that represents half in our base 10 system is 5. Hey, Just what we found out before. But this is a picture model that shows why it works. I thought that was so cool. So we've already established the first 4/8. 1/8 is 0.125. 2/8 can be simplified to 1/4, which we know is a quarter. And a quarter is worth 25 cents, or 0.25. 3/8, well, we can use the facts that we know before from 1/8 and 2/8 to add those together and get 0.375, 375 thousandths. And then we get to 4/8, which can be simplified into 1/2, which we know as the decimal 0.5. So now what? Now we need to set up our paper for 5/8, 6/8, 7/8, and 8/8. Okay, for 5/8, we can't simplify that fraction into a more friendly fraction where we've already figured out the decimal. So there are a few different ways to do this. You could do 5 groups of 0.125, basically 5 groups of 1/8. You could definitely do that. You could do your 2/8 plus your 3/8, so your 0.375 plus 0.25. Or you could do 4/8 plus 1/8. In terms of friendly numbers, that's what I'm going for. So 4/8 was 0.5. And if I want to add 1/8, 1/8 is 0.125. I'm going to show you the traditional algorithm for adding and subtracting decimals here. Well, we need to put some placeholders in. I can't take, and the placeholders, just keep it nice and make sure that you've got them all in the right places, because I just can't take it when students are all over the board and not keeping track of place value. Okay, so we have 5 thousandths, we have 2 tenths, and now we have 2 hundredths, and now we have 6 tenths. So that is our answer, 0.625 as our final answer for 5/8. Okay, let's go on to 6/8 here. Could we simplify this fraction down so that it's more friendly by dividing the top and the bottom by the same amount? If we divide both the numerator and the denominator by 2, we would get 3/4. 3/4, 3/4. How much are 3/4 worth? We said that over here, 1/4 was worth 25 cents. So how many cents would you have if you had 3/4? 0.75. Awesome. Okay, 7/8. This one can be kind of ugly, but we've got plenty to work with here. Lots of different strategies for figuring out your 7/8. You can always go back to remembering that 1/8 is 0.125. You could add that up 7 times. There might be some more efficient ways to do it, though, possibly. Think about your facts that you have with you so far. You could add what you got for 6/8 to 1/8. That might work. You could do that if you want to. You could also add, 7 decomposed as 3 and 4. You could add your 3/8 plus your 4/8. Ooh, that might be nice because this is just a single digit. I think I'm going to do that. Okay, so I decided to do the 3/8 plus the 4/8, and that makes 7/8 there. I've decomposed my fraction, and I'll know what to work with. 3/8, we said, was 0.375, and 4/8 was 0.5. Notice that we are keeping our tenths in the tenths column, hundredths in the hundredths column, and thousandths in the thousandths column. Okay, and now all we need to do is add these up. sometimes it's nice to have placeholders so that we don't get confused. Okay, 5 plus nothing is 5. 7 plus nothing is 7. 3 plus 5 is 8. And bring down that decimal. I always sing, bring down, oh, bring down thy decimal to me, to me. Bring down, oh, bring down my decimal to me. Yeah, the decimal makes a difference. If you didn't have the decimal, you would say that 7/8 is the same as 875. Wrong. It's the same as 875 thousandths. Okay, moving on. 8/8. Well, 8/8 is an improper fraction that can be simplified into a whole number. 1. So our decimal equivalent is 1. Yep, Captain Obvious. Save him for last. All right, let's talk about fifths. What's 1/5 worth as a decimal? What is an equivalent decimal for 1/5? Well, there are a couple of cool ways of thinking about this. If you were to divide $100 into fifths, 5 equal parts, how many would each of those 5 people get? So say that I had a $100 bill that I brought to the classroom, and I decided that Alex, Brooke, Bo, Landon, and Cam could split it evenly. How much would each one of them get? I hope that by now you've had enough time to think about that and realize that they would have each gotten $20 bills. One $20 bill would split that 100 in half. So 1/5 is equivalent to 20 hundredths, 20 out of 100. Now, you don't really need the 0 there. So if you don't want it, you can erase it. But I like it because it helps me remember that it's like the $20 bill. And I can take $20 bills and make 5 of them and get to my whole number. Same way as if you have 5 nickels, or if you've got nickels, fifths, you would need 20 of them to get to a full dollar. So you could think about it in terms of money. There's another way of thinking about it that I didn't even know until this year, and it's really cool. Okay, here we go. Let's change 1/5 into an equivalent fraction with 100 as the denominator. Why would we want an equivalent fraction when we're trying to get to a decimal? Why would we want 100 as the denominator? Well, if 100 is the denominator, then we would say it's something hundredths. Just like over here, 20 hundredths. So that denominator of 100 can really help us plug in a fraction that goes to the hundredths place. Okay, so let's make our equivalent fractions. We've gotten really good at doing this. 5 times what is 100? 5 times what is 100? You could think, well, 5 times 10 gets me to 50. Double that. 5 times 20 gets me to 100. So multiply by 20. And whatever you do to the denominator, you have to do to the numerator. So times 20 again. 1 times 20 is 20. Now, if we were reading like math pros, how would this fraction sound? 20 hundredths. Now, if I told you, write 20 hundredths in decimal form, how would you write it? 20 hundredths. In fraction form, right here, and in decimal form, right there. So let's see if we can use our knowledge of what 1/5 is, basically 0.2, to figure out all the rest of them. And we have written it as 20 because it can remind us of the $20 bill. Now though, I'm going to erase that 0 because a math pro would know we don't really need it. Okay, so if 1/5 is 0.2, how much would 2/5 be worth? We've doubled it. We've doubled our fraction, so let's double our decimal. So double 0.2 would be 0.4. What about 3/5? If our pattern continues where we're doubling and we're getting one more on there, we've got doubled here, but just adding one more here. So here, we just added one more here. So here we need to add one more group of 1/5. We need to add another 0.2. So we will see a pattern start to emerge. So that would be 0.6. 0.2, 0.4, 0.6. What do you think about 4/5? 4/5, 0.8. And 5/5, 1 whole. Okay, now we're going to work with some really, really friendly numbers. Nice, friendly numbers. Tenths. Because the place right after the decimal, yeah, that is the tenths place. So whatever the numerator is, you just plug it into the tenths place. And you would say it the same way. So if we are looking at 1/10, that means that this 1 is going to travel into the tenths place. One-tenth. What about 2/10? 0.2. And a math pro would say this as 2/10. Hey, 2/10. There you go. That's why tenths are such friendly numbers. Okay, let's keep going here. 3/10 would be 0.3. Try to beat me. 4/10 would be 0.4. 5/10 would be 0.5. 6/10 would be 0.6. 7/10 would be 0.7. 8/10 would be 0.8. 9/10 would be 0.9. And 10/10, well, I couldn't do 0.10 because that really means that there's a 1 in the tenths place. That's not what I wanted. If I have 10/10, I have 1 whole. Ten-tenths can be recombined to make 1 whole. So those are some nice tenths to work with. Okay, our last set of fractions to show decimal equivalents for are 20ths. They sound really unfriendly, and I always thought they were. And then a couple days ago, I learned a trick, and I'm going to share that trick with you. So remember how we have learned to make equivalent fractions? Well, if we can just get the fraction denominator to be 100, then that means that we can be working with the hundredths place when we come to decimals, which is nice. So think about how to get a numerator that matches. What did we do when we went from 20 to 100? What did we multiply by? In other words, how many groups of 20 does it take to build 100? 5. And whatever you do to the denominator, you have to do to the numerator. Got to treat them fairly. So that's going to be times 5 there as well. So 1 times 5 is 5. So we've got this 5/100ths. Which way do you think the correct way is to write 5/100ths? .5 or .05? Well, we better read them the Math Pro way. How would a Math Pro read that number? 5/10ths. How would a Math Pro read this number? 5/100ths. Hey, that's what we wanted. We wanted 5/100ths. So that is our correct answer. So 5/100ths for 1/20th. And then we can figure out the rest from there. If we were given 2/20ths, knowing that 1/20th is .05, how could we figure out what 2/20ths were worth? Well, you could do .05 plus .05 and come up with a .1. Or you could look at the 2/20ths and say, hey, I can reduce that fraction. That's the same as 1/10. .1. Lots of good strategies there. On your odd number 20ths, you're not going to be able to reduce to the tenths. So that's a bummer. But we have ways of figuring it out. 3/20ths, well, we had our .05 for our 1/20th. And we had our 2/20ths already figured out as .1, and I'm going to fill in a zeroed placeholder digit there. Let's add them together. .15. So that means that our decimal equivalent of 3/20ths is .15. And you can continue building and reaching landmark fractions all over the place. For example, the next one would be 4/20ths. Well, if you simplify that, you might just come up with another fraction that you've already worked with. And you can automatically know the decimal equivalent. Now, this is a hefty lesson. There is a lot to learn in terms of decimal equivalents, and you can always take it further and do the butt cheeks and figure out the percentage too, although that's a 6th grade standard. So, but I like to mention it anyway because I think you guys can really learn it. There's a lot to learn that you're expected to know at a 5th grade level. You're expected to know 20ths, tenths, fifths, eighths, fourths, and halves. Man, that's a lot. So the best thing that you can start doing is you can start chunking away at them. First, learn all of your halves and fourths. Then learn all of your eighths. You should already know your tenths, hopefully. Tenths could help you figure out your fifths. Tenths could also help you figure out your 20ths. So you can use these facts, use as many as you can, as many strategies as you can. You might not actually end up having to memorize all of this. If you memorize a few facts, you might be able to use them to help you figure out all the rest of them. So I don't want you to feel like you have to memorize everything in this 40-minute lesson. But memorize enough that you will then have the tools and the numbers you need to figure out the rest. We are going to be working really hard on this. This is one of the last things that we have to learn in fractions. We have really been flying along, and it's been awesome seeing how hard you guys are working, and I can't wait to see how hard you are working tomorrow as well. There's no task for you to do tonight other than to come prepared for a group discussion problem that I am going to give you, and it is going to have to do with fractions and decimals.